thrilled. We had no yet. So we're it's really really a pleasure to see all of you here. We thank you for your presence. It means a lot to us. And so we'll try to keep doing these. Some will be, depending on speaker availability in New York, we're going to do some, continue to do some remote and do as many as we can in person, and hopefully sort of start to foster a sense of community in this group. And so we look forward to getting to know you all better. And if you have any requests or you know, whatever you want to volunteer to speak, you're all welcome. So that's it. So anything else you want to say?
No, that's great.
Is it at this location?
We will always host at this location. Yeah. Cool.
That's yeah.
Good.
What are you thinking about having like on a recurrent monthly basis, for example, in person? That would be wonderful.
Okay. Yeah. Schedule's allowing.
Yeah.
Yeah.
Not in December.
Yeah.
Or some.
Okay, so we'll turn it over to Samuel. So we're really thrilled. I think this has been a great synergy. I think maybe part of it is people like a good response anyway, but I think part of it is probably the appeal of EKS as a topic. So we're really thankful to you. We're honored to have you as our first in-person guest. And we're recording. Yes. Okay. Cool. All right, Samuel.
Awesome. Oh, thank you so much. I just want to say thank you for Gabriel and Cora. I reached out, I don't know, like maybe fun story, 4 or 5 months ago. I've been trying to do more speaking outside. I think it's good to just, you know, share with the community. I do a lot of speaking internally at AWS. I'll talk who I am and not, but I reach out on, I just research on Meetup. By the way, I'm new to New York. I've just moved from Vancouver to New York less than a year ago, me and my wife. And so this is my first actually in-person talk from the community in New York. So it's good to see, that the community is vibrant and people are excited to be after the pandemic. And they've been just great. I thought, hey, I think you've been doing a lot of the virtual ones and said, let's just try to be in person. They're super open to the idea. So I think this is going to be recorded and you're going to share on YouTube sometime. So yeah, people can also have both ways. But enough about that, and let's just actually get started. So my name is Simon Barufi. I am a Senior Solutions Architect with AWS. I've been with AWS for close to 4 years now. I'm not a specialist on container, but I do talk with containers with a lot of the customers. My day-to-day is supporting global financial services companies here in New York and around the world on their journey on AWS and on the cloud. As you can imagine, a lot of companies are opting as their container orchestration Kubernetes, right? And that's kind of our managed offering. So before I get started, just want to set expectations. Maybe let's just, raise your hand if you already have worked with Kubernetes. Okay, a couple of people, good. So the reason why I ask that, this is going to be an introduction to EKS. There is a little bit of an expectation to know containers. I'm not going to be covering what is a container, how to get started with a container. So maybe if you're not familiar with container, that might be a little bit challenged. But please, if you don't follow me, just raise your hand, ask a question, and you can make this as interactive as possible. I do have content for an hour with the demo, depending how we do. So don't be afraid of asking questions. What I'm going to do is I'm going to start with just the basics. What is Kubernetes? A little bit of the history about Kubernetes. Then I'm going to jump into the AWS ecosystem. So the first part is not going to be specific to AWS, it's just going to be more generic of what is Kubernetes. Then I'm going to talk what is EKS, why EKS exists, how companies use EKS. And then I'm going to, the first 2 topics are going to be more introduction level. Then I'm going to get into the weeds of how EKS is, how you AWS manage EKS, how can you expose an application with EKS, each cloud provider will be a little bit different, how you expose applications, how you manage storage with your EKS, how you manage observability, how you manage scaling, and finally security. So I'm going to not go in depth on any of those, but I'm just going to try to give you an idea. If there is one thing I would like for you to just take away from this learning today is just what is a managed service and why companies choose to use a managed service versus just running their own Kubernetes, and making that decision if you are a decision maker in your company or if you're already using Kubernetes. That is actually one of the things I hope you to learn today. And, I haven't recorded the demo, so this is going to be a live demo. So hopefully it goes well. It's not anything fancy, just a simple demo, but you never know. So I'm just going to get out of the way right now. So quickly, what is Kubernetes? So Kubernetes, it's a open source container orchestration solution. If you're familiar with Docker, if you have used Docker in the past, you can install Docker on your machine or on your server, and you can easily run a container. It's very easy. We just run some commands, Docker build, Docker run. You can expose applications with your laptop on servers, very easy. The challenge that if you've used Docker, and by the way, I've started using Docker maybe 2015, and you mentioned Mesosphere before, right? At that time, there wasn't really a winner when it comes to container orchestration. People were just installing Docker on their servers or on, just on their laptops, and they were playing along because it was really new, right? One of the challenges that companies quickly realize is once you have a container and you need to expose the container or run the container in production, there are a lot of things that Docker didn't do at the time, right? Just, running containers, such as how you manage a horizontal scalability of your pods, how you manage security, how you manage fault tolerance. All those things didn't, Docker didn't help with that. Docker made an amazing job. And I think, Docker have been great to the community to popularize containers. How can you easily run containers? That has been a great mission of Docker. But then the other part is when you look at production is how do you actually run those containers at scale? And this part here is for me, one of the main reasons. So back on my story, right? When you look in 2016, there wasn't a clear winner. You have like Docker Swarm, you have Mesosphere, you have Kubernetes, and you have potentially other solutions that were competing to be these, lead container orchestration. Why did Kubernetes become that solution, right? I have my personal opinion. I think people who have different approaches. I think because the community, just because the open source community, and this is one of the things that Kubernetes is good at, is you can run on Microsoft, you can run on AWS, you can run with VM or Tanzu. It's still containers. The way there'll be differences how you manage, but the main thing is open source Kubernetes. So the community plays a big role. If I'm not mistaken, if you go to GitHub and you check the Kubernetes project, because it's open source, it's either number 1 or number 3 of most committed projects, right? So you could.
Kubernetes number 2 is Sigstore.
There you go. So Sigstore, it's also part of Kubernetes. So I appreciate it for that. I thought it was Linux, but anyway, maybe it surpassed Linux. So the main thing here that I think is good about Kubernetes is companies can build on top of Kubernetes. Kubernetes, the whole platform is based on API driven, and you can actually create on top of Kubernetes. And that's why it's being so popular. Instead of just telling companies how to use Kubernetes, they created an API environment and you can build on top of Kubernetes. A little bit of history for people that are not familiar at all with Kubernetes. Kubernetes came from Google. Google open source Kubernetes, I would say 2014. Don't hold me accountable on those dates, but I think it's 2014. And it came from an internal project called Borg. Google as a company has ran containers for many decades. You can run containers on Linux for many, many years with LXC containers. Google had this project called Borg, and I think 3 or 4 individuals look at that, look at the industry and realize, what we have here could be really powerful to the community. So in the beginning, they actually just open source on the repository they were owning. And I think it was 7 months after they donated the project to something called the Cloud Native Compute Foundation, CNCF, and they actually donated a bunch of money. So what they did by that, in just easy terms, they gave the project away and they have no control. They gave the project away for the Linux Foundation, and the Linux Foundation now, as a community, has the the say and the contribution across many industries. That. The experience that Google had running containers and being community-driven and also giving you an infrastructure and a platform that you can build on top, in my opinion, is the reason why companies adopt Kubernetes and are still adopting Kubernetes. So, I don't want to bore you with this slide. There is a lot here. And the main reason I put this slide is to talk about 2 things you hear me talk about throughout my presentation: control plane and data plane. The way Kubernetes architecture is created is you have a control plane, which you can think about the brain, where it's every single action that you're gonna do within the Kubernetes ecosystem, you're gonna send commands to the control plane. And there are a few pieces with the control plane. You have, the data store, which is a etcd database. You have the API server, you have some schedulers, and you have some controllers as well that all live with the control plane. In reality, if you manage your own Kubernetes, you could potentially run your applications as well within the control plane. And think about the control plane as just, virtual machines or servers, right? It's not a good recommendation that you run your applications there, but you could. There is nothing preventing you. What is important for your application, let's say you have an API and you run an API, a Python API server. You're going to run within these 3 boxes here, or many boxes. It can be, I think currently Kubernetes supports up to 5,000 nodes, and there is a project, I don't know if it's released or not, to support 15,000 nodes.
OpenAI right now is running on 7 on Azure.
Yeah, there you go. So it's called super or B cluster. So you can actually increase those nodes exponentially. So 3 is just a demonstration of how many you can run. The main thing about managed Kubernetes, which you're going to get in a moment on EKS, in my opinion, and this presentation is opinionated about me, so I'm going to be very clear about that. You are not, unless you are a cloud provider or VM, or your job is not to manage control plane. It gives you 0 benefit to manage a control plane. Your job is to deploy your applications that will provide value to your customers. Either if that's a mobile application, if you're OpenAI, whoever you are, your job is to serve your customers. And very little case, in very few cases, it's going to include managing control plane. Not to say that you can't. You can just copy the GitHub project for Kubernetes and deploy Kubernetes on your own. And there is actually, if you are not familiar with Kubernetes and you want to see how hard it is to manage your own Kubernetes, there is a repository from actually one of the main developer advocates on Google, Kelsey. It's called Kubernetes the Hard Way. And it goes step by step about how you would actually, clone the repository from Kubernetes and deploy on your own virtual machines. Please go through that. After you go through that plan, you say like, nah, I'm not going to do that again. I did a few times, like, nah, this is just too much. Every time I talk to customers, they're like, oh yeah, I'm managing my own Kubernetes on my virtual machines, EC2s or whatever. I was like, why are you doing that? Like, is there a specific reason why you need to do that? 99% of the time, it's just because people like control. And sometimes it's not the best idea. So I talked about architecture at very high level. How do you, as a user or someone that is in a working Kubernetes, how does it actually work? When you deploy Kubernetes, you're going to have an endpoint. That it's going to be your cluster endpoint. That endpoint is nothing more than an API. So remember, it's an API-driven architecture. The way you tell Kubernetes to do something is by creating some sort of objects. And on this list, you have a lot of objects. I'll talk about a couple. So pod. You probably have, if you've been reading or learning Kubernetes, there is no terminology. There is terminology, but there is no concept of deploying a single container. The way you deploy a container on Kubernetes, the smallest unit deployable on Kubernetes is a pod. For the sake of today's presentation, let's just think as a pod as one container. You can run multiple containers as a pod, but just for the sake of presentation today, it will be one pod equals one container. So that's the smallest unit of deployment you can actually do in Kubernetes. Daemon set, I'll talk in a moment. Deployment. So remember, I talked one of the challenges of running Docker is if you install Docker on your machine and you have, or let's say in a Linux server, and you deploy an application, the Linux server, how do you make that application scalable? If you have like a peak of hundreds of different users trying to call that specific API, Docker doesn't do anything. I mean, you could use Docker Swarm, but nobody's using Docker Swarm anymore. Yeah, exactly. I wouldn't recommend that to use. Yeah, so there are still customers, but it's more legacy. Exactly. It is that, yeah. So with deployment, deployment is one of the most important concepts on Kubernetes. Deployment is the wrap around a pod. So when you do a deployment, what you say to Kubernetes, like, here is a container that will live inside a pod. please help me manage multiple replicas of this pod across your cluster. And remember, a cluster can have hundreds of nodes or 2 nodes or 3 nodes. You can go from 0 to 15,000 nodes currently. With a deployment, the way it works, and there are a lot of benefits. You can create a deployment on my demo I'm going to do. I'm going to say, create a deployment with this container, with this pod, and replicate this pod 3 times. What deployment you do using the control plane of Kubernetes, you guarantee, as long as I have resources available on my cluster, that I have 3 pods running at any time. That means if one of the virtual machines or one of the servers that is running one of the pods die, Kubernetes will be aware because it's monitoring your, how the pods are being deployed, and it's going to deploy another pod in another virtual machine or another server. So deployment is really good. And you can actually do rolling updates. So if you have 10 pods and you want to slowly upgrade your application, so if you have a bug, you don't get the bug for all the people accessing, you can slowly rolling across all the pods on the deployment. Another one I'm going to quickly talk about it is service. So you have this pod and you have this deployment. Let's say it's an API and you want to expose an API to the public or an internal application. You need to expose that some sort of fashion, right? You need to have some sort of load balancing across all the pods that you have, because by the end of the day, your goal is for one person that is requesting or sending an API request to somehow fit in one of those pods. If you have 10 pods, how does that data get from your request to one of those pods? The way we do that is by service. So the service is a map that you created on top of either a pod or a deployment, saying, and on them we see, you can either do a service internally, so internally for the cluster. So only, let's say you have another pod within the same cluster. Let's say you have a job that needs to call an API, and they both live on the same cluster. They don't need to leave the cluster. They can just talk internally, within the cluster. It's called cluster IP service. But most of the time, you want to expose that to the end world. So you might want to create a public load balancer on your cloud provider that customers are able to just go to the load balancer, and magic happens within Kubernetes that actually loads balance your traffic from all the pods you have available. Last thing, namespaces. So you have this cluster, right? This cluster can be big or small. When you deploy any type of object, you need to deploy those objects within a namespace. And a namespace is nothing more than a logically named group. So let's say you have an application or a group of applications that you want just to have you can create isolations, but by default, namespaces doesn't isolate anything. But let's say you just want to isolate in a way that you can easily see what you've deployed, you create namespaces. And namespace is nothing more than, just a logical construct. And you can build a lot of, architecture on top of namespaces. And you can have many namespaces within your cluster. So before I move forward, any questions on, basics of Kubernetes, some of the objects you can deploy, anything maybe? Yes, of course. I'm good, thank you. I already ate one. Yes.
So the deployments and replica sets be on the same layer?
Yeah, so good question. I didn't touch on that. So when you create a deployment, behind the scenes, you create a replica set. And that's what is actually defining the amount of pods that you have available. So you don't need to create a replica set manually. When you create a deployment, if you actually go and you do, run some commands to check the replica set, the deployment creates one automatically for you. Yeah. Yes.
Does a replica set manage daemon sets?
I don't think it does, because daemon sets are not. So I think it's a scheduler on the control plane that will talk to the kubelet, and I'm going a little bit in that. But the kubelet will just talk to the control plane, because, by the way, daemon sets, if I have 5 nodes, daemon sets are going to tell each node to run one version of that specific container. So a good example for daemon set is, let's say you have a log aggregation for your observability, and you want to have that log aggregation every single node because you want to collect the logs for all the cluster. That is when you deploy daemon set. I will need to check that, but I don't think it's the replica set that deploys. I think it's just the control plane a scheduler that is just going to talk to kubelet and deploy one each. Because you don't scale replica sets, you just go one each. Oh, sorry, you don't scale daemon sets. So you're only going to have one per node. Does that answer the question?
But not just down, the daemon set is gone.
Yeah, because daemon sets just run on every single node. Yeah, and you see, I can on my demo, I can show you some examples of daemon sets. But yeah, replica set, I don't think has any interaction. But I don't want to say 100% because I'm not sure. So we can check on that. Awesome. Any other questions? Okay. EKS. So we talked about Kubernetes, high level, upstream, open source, all that. What is EKS? Well, EKS is a managed service on AWS, so AWS cloud provider, that helps you a lot of things, right? So when you create EKS, first it's a certified upstream version of Kubernetes, meaning that the way you integrate and the way you use Kubernetes on EKS will be the same as if you're on premise or if you're on other cloud providers. There is no difference. I mean, there are differences, but it's certified, with security fix and all that. This is an important thing that I've been talking to so many customers about this. Kubernetes, I think right now is not as popular as it was maybe 2018, 19. Every exec that went to a conference would talk about Kubernetes, right? And they're like, yeah, we need to implement Kubernetes. Go and implement Kubernetes. Kubernetes is amazing. It's going to solve all my problems. The thing that those companies didn't understand at the time, and I think they don't yet, is Kubernetes has a release date. So every 4 months, so it used to be every 3 months. Now every 4 months, they release a new version of Kubernetes. Each version, the community, the Kubernetes open source community, will support security patches for like 12, 13 months. After that, you're out of luck. You got to upgrade. So one of the things that customers don't understand, and hopefully I can pass that message, is if you choose to use Kubernetes, it comes with a lot of responsibility of upgrading. That's called, the cluster life cycle. It's really, really important that you have that in mind. I couldn't even enumerate the amount of times I've been on call with customers asking for exception because, it gets to a point that EKS, AWS is going to say, you're running a very old version. It's a security risk. You cannot keep running this version. We are going to force you to upgrade this because if you keep running, there will be potentially security vulnerabilities that you run. So, yes.
And then they're liable, right? That could be a legality issue.
Yeah, so by using a managed service like EKS, you see, I'll talk in a moment, the difference between a control plane and a node group, like a data plane, how those are different. By default, EKS, if you don't upgrade the end of support or end of life version of Kubernetes, it's going to automatically upgrade within a couple months the control plane. So it could have in breaking changes. Yes.
It's always the case that the juice version is backwards compatible with the old ones.
No. So very good question. So yeah, so Kubernetes is a very fast-paced open source project, right? They do a lot of innovation and changes on things they got wrong in the beginning. The way it works, and this is is not 100%, there is edge cases. By default, Kubernetes tries to keep the control plane working in harmony with the data plane with 2 versions discrepancy. So if you have like a 1.21 and 1.23, it should still work. But there is a big but. If there is an API that you're using that has been deprecated on like one of those 2 versions that you have a mismatch, you're out of luck. Because you're going to try, whatever application you run is going to try to talk to that API doesn't exist. So I think the community is doing a much better job lately, and also cloud providers, of helping customers. Because right now, if you have a cluster and you look at that cluster, it's really hard to know if you're breaking, unless you go in depth. It's really hard to know if you have things and APIs that are breaking changes, right? So I think the community is getting better at that and doing less breaking changes. But for an example, we are now on version 1.26 of Kubernetes. EKS supports 1.25. It's about to support 1.26. From 1.21, from 1.24, each version you actually upgraded, it's very likely you're going to face breaking changes. So it's a very good question, and a lot of people don't realize that until they are too deep in the trenches. I was like, I wish I knew that before. So hopefully that's one thing you can, comment on it today. So EKS will support 4 versions of Kubernetes at any given time. You can pick and choose. I think right now it supports 121, 22, 23, 24, and 25. Or sorry, 20, but yeah, 5. It's 4, 5, but one is about to go end of life in a couple of weeks. So, okay. What EKS helps you build a reliable and stable and secure application in virtually any environment. This is just kind of a little bit of marketing. This data is a little bit outdated because I don't think the Cloud Native Cloud Survey has been done for 2022 or release. I think this is just the latest version we have. And you can see how shocking it is. 96% of organizations are either already using Kubernetes or evaluating to use Kubernetes. So if you're an engineer and I think it's a valuable skill to know. At least just be aware of what it is, because if you move jobs and you're there is a chance you're actually using Kubernetes. In 2021, there was 5.6 million developers using Kubernetes, and that was like an increase in 67% year over year. That's kind of mind-blowing. And this is just a little bit of marketing. EKS is the most popular managed Kubernetes service available. On 39% of the respondents have actually opted into EKS. Okay, enough about kind of marketing. Why is EKS good, and why should you use EKS or a managed service? Remember how I said there is the GitHub repository called Kubernetes the Hard Way? If you use EKS, you don't need to manage your control plane. That's one of the main benefits of a managed service. You go to AWS APIs or console or CLI, you request to create a cluster, and this is control plane. So it automatically scales the control plane for you behind the scenes. So it's always running at least 2 nodes on our environment. You don't get to see. The only thing you get is an endpoint. You get an endpoint, and you talk to the endpoint and you create resources. So the etcd data store, the API, the controllers, the schedulers, and especially major version upgrades that you need to do manually, you now don't need to do anymore. So it's all done automatically. Now on the customer side, where you have actually your applications, there are different ways and different things you can do. The most common, which I'm just going to focus on this, we can talk about self-managed groups later, is manage no groups, which is an answer that AWS will also help you manage the data plane. So instead of you actually spinning up EC2 instances and connecting that EC2 instance with Kubernetes and your control plane, AWS is going to manage that for you. And by now, there is another thing here that you might ask what that is. Fargate is a serverless way to deploy containers. So what that means is instead of actually using a virtual machine or like a EC2 instance, you can actually automatically just request AWS to run a container for you. And it runs on our background. You don't get to see any infrastructure. You don't care about anything. It just deploy the container for you.
Question. So
yes,
long term, and I was doing some research in terms of serverless via Fargate or other serverless function solutions that are using Knative.
Yeah.
What is the cost benefit analysis as it relates to like EKS versus Fargate? Is it depending on the type of frequency of command, like of calls?
Yeah.
What as an architect, if I'm going to deliver a service, why would I choose one versus the other?
Yeah, that's a good question. So, by the way, Fargate works on EKS, so it's a complement of EKS. You don't only run Fargate, you run EKS, and then you integrate with Fargate.
Just Fargate, right?
ECS, then is ECS, which is a different offering on AWS. It's called Elastic Container Service that has nothing to do with Kubernetes. Then, yeah. Yeah, exactly. Yeah, yeah. So the reason, one of the benefits that you might, so it's more if you do a comparison of having managed node groups on EC2 versus Fargate. And let's assume you have 90% utilization in one EC2, it's going to be much cheaper to just run EC2s rather than Fargate. The benefit that gets with you is now you don't need to manage version upgrades in Kubernetes. All the infrastructure is managed for you. There are some gotchas. You can't run daemon sets on Fargate, so there is some limitations. And the reason why I've seen customers choose Fargate is just ease of use. They don't want to care about, a node on an EC2. They just want to deploy a container.
Developers can care about.
Yeah, exactly. And, there is good use cases and potentially, not good use cases. Okay. No, my pleasure. So here you see the control plane architecture. I kind of mentioned that. So on the top, so this is actually all the control plane. So it runs at least on 3 availability zones on a specific AWS region. By default, you always have at least 2 API server instances. You have an endpoint and that is load balancer into that instance. And then you have at least 3 copies of, this is the most important thing of the control plane. If you lose this, your cluster is gone because that's all the data and the state of your cluster lives within this etcd instance, which is just a database. So an availability zone can go down, your control plane is still up and running because we are managing that for you across your availability zone. And if you get more load, that's transparent for you. If you're hitting the API on EKS very heavily on the control plane, this is going to scale. So it's not just static. You get support, you have, 3 nines of SLAs, 99.95% of SLAs, and 24 support, and you automatically resize. So this is the thing that you shouldn't care. Like this slide shouldn't care less. It's just let the cloud provider manage for you. So data plane, I talk about it, how you can actually manage. I'm just going to quickly talk about it again. You can either use a node group with EC2s, or you can use a serverless offering with Fargate. If you use the EC2 version, on your account, on your AWS account, if you go on EC2, you're going to see those EC2 instances that gets automatically created for you and managed by EKS. If you go with Fargate, you're not going to see anything. It's running on our, yes.
So EKS managers can manage AWS compute instances.
Yes.
What about non-AWS compute instances?
That's EKS anywhere. So you can deploy EKS, which is also upstream supported version of Kubernetes. You can deploy that on your on-premise or potentially on other cloud providers or even on Outpost. Outpost is just like a hack that AWS gives you to put on your data center, and it talks to the cloud, but the data will live within your on-premise. You can do that, but the way it works is very different. So some of the differentiators and benefits that you get with managed control plane are still on EKS anywhere, but because now you're limited to how it works on other cloud providers and on-premise, it's a little bit different. So that's kind of a different conversation, but you can. Yeah, so you have Fargate and data plane nodes with EC2. So EKS has been evolving as a service, and I think it's one of the most fastest growing services on AWS. 3-4 years ago, we didn't have this option of managed node groups. So what does it actually mean? It meant that Kubernetes EKS could manage the control plane, but the data plane was not managed for you. You needed to spin up your EC2 and do the work. That option is still available. One of the things I think AWS is really good at is not deprecating stuff. So it's still supported there. You shouldn't potentially use, but it's still supported. And then we announced manage node groups, which is a way that is going to automatically manage an auto-scaling group for you, and is automatically going to manage all the EC2 instance. So when you're doing, as an example, when you're doing a version upgrade of Kubernetes, either a minor version or a major version or a minor version, EKS is going to go talk to the auto-scaling group and automatically, upgrade that for you, which on self-managed node group, every time there is an upgrade, you need to go and do it yourself. So just a little bit about Fargate. When you run a Fargate, it runs on AWS accounts, meaning like on our infrastructure, on our account, you don't see that. But one of the questions you might ask, well, like if you're not running on my account, how do I actually have access to that pod, right? The way it works is it creates a ENI within your account. ENI is Elastic Network Interface, and gives an IP address of your VPC. So every time you are on your Kubernetes cluster and you're talking to the Fargate pod, it goes actually through the AWS backbone privately and talks to AWS. And here you can see some of the considerations. I think you're asking when to use. There are some things that you can't use. For example, you can't use network load balancer. A Fargate cannot be a daemon set because there is no node. Yes?
So since there was a daemon set, how do you do observability
That's a good question. So there are ways you can do it sidecars. And there is actually a good blog post, and I can share with you that kind of packages all it up within a container, just as a layer on your container that has that observability. And if you're using CloudWatch, there is a lot of integration. CloudWatch is a monitoring service on AWS. You can use just CloudWatch, and it natively integrates with Fargate. But if you're using other third party, then you might need to use a side container on your pod. Any questions? So how do you expose? So you created your application, you deployed your pods. How do you actually expose now to the internet or internally? There are a couple ways. I'm just going to cover this because it's part of my demo. You can create an ingress object. And an ingress object, think of like, a way that you can have a domain and you can use URIs to redirect that specific path to specific services. So in this example, we have food.mydomain.com. Let's say when you go to the main path, food.mydomain.com, it goes to a specific service and a specific deployment with pods. But if you go to /bar, let's say it's an API, go to API version 1, it goes to a specific service and the pods. And by the way, these pods here could be managed by a deployment. Deployment is not shown here, but think of these as within a deployment. And you can have many others. That's just one of the many ways you can expose applications in Kubernetes. I'm not going to be able to cover all of those. But the good thing about Ingress, it kind of talks at the layer 7 of the OSI stack. So it's HTTP and HTTPS, and is able to look at HTTP headers and decide where to go. Okay. Now, one question. When you are running on AWS, you want to integrate with AWS native services, AWS native load balancers. By default, when you deploy EKS or you deploy Kubernetes, Kubernetes has no idea how to talk to AWS and create infrastructure on our behalf. You can install on your cluster something called the AWS Load Balancer Controller, which is literally a deployment type on your cluster. And that deployment will be responsible for watching your cluster. And every time you create a service of type, you can see like either ingress or network ingress or ingress class, or even load balancer, what it's actually going to do is going to go and talk to the AWS cloud, provision a load balancer for you, and link the load balancer to your nodes. So it's going to manage the network for you. Let's say you want to use all the benefits of an application load balancer. If people are not familiar with application load balancer, it's just a layer 7 load balancer on Kubernetes on AWS. And you can actually deploy these to integrate with the cloud provider. So there are some custom resources and some things you need to do to get that prepared. But once you have, as a developer, if the cluster is ready, you deploy your application, you deploy the service, and you deploy an ingress type, behind the scenes, magically an endpoint with a load balancer gets available for you, and you round robin the traffic across all the pods on your cluster. On the demo, if that doesn't make sense, I'll have, yes.
It deploys a new load balancer every time, or it can reuse an existing one? Because, I mean, it can break load balance if you start deploying load balancer.
You can choose. So you see here, there is a target group binding. So if you choose an ingress type, like you saw here, you can just have one load balancer, and then you have multiple rules within the application load balancer that will redirect. But if you, let's say you want to do a network load balancer, which is not a layer 7, you can actually create a target group, which is behind the scenes what decides where the load balancer goes, and then just attach that to an existing load balancer. And if you're curious, you can just go to the AWS Load Balancer Controller documentation, and it'll tell you exactly how you can do that. Any other questions? Cool. So let's talk about the scaling applications with EKS. This is not, this is not EKS specific, these two. But one of the things we want Kubernetes to take care for us is, if my application has an increase of load or a decrease in the load, I want Kubernetes to actually either increase the replicas of my application or decrease the replicas of my application. With HPA, which is short for horizontal pod outscaling, you can create an object called HPA on your cluster. And that object within the cluster is going to look for metrics that you define. So let's give an example of CPU. If you want to say if the aggregation of your pods on a deployment goes above 80%, you want Kubernetes to deploy another pod for you. So automatically increase the replicas. That's how you do with HPA. So it's automatically going up and down for you. So it's kind of an auto-scaling for your application. One important thing I want to talk about it doesn't scale your cluster. It scale your pods within your cluster. So if you only have 3 nodes on your cluster and you have no auto-scaling mechanism for your nodes, and you have HPA trying to spin up 100 more pods because you have a huge increase of load, it's not going to do anything. Those pods are going to be pending. So you need to have a combination, and you see why I'm talking about it. You need to have a combination of also a cluster auto-scaling solution. So horizontal pod, as the name says, adds a new replica of the same pod version, which is commonly used. Kubernetes is really good at microservices. So those are normally stateless that can just be spun up as many versions of that pod as you want. That would be a good idea. Now you have vertical pod outscaling, which is instead of adding more of the same, increases. It doesn't actually automatically increases. You go and actually create a new pod with more memory and more CPU. To be completely honest, I would say 90+% of companies will just use HPA. There are use cases that you might be using VPA, but VPA is not as commonly used as HPA. So we talked about how you outscaling your application. Let's talk about how to actually scale your nodes, right? So you want to use a combination of both HPA and cluster autoscaler, because cluster autoscaler, what it actually does, once you have pending pods, so let's say you have a cluster with 3 nodes, and those nodes are fully utilized. There is no more resource available to deploy anything else. If you install cluster autoscaler on your cluster and you properly configure, cluster autoscaler will look for pending pods. It's called unschedulable pods. And you will say, well, I have these pods that you're trying to deploy, but I don't have space on your cluster. So it's going to go and create more nodes for you. Those nodes are going to be EC2 instances that are going to be spun up, and it's going to attach to your cluster. So all the manage, of bringing the Kubernetes up is going to be made for you. So one of the things I want to focus on cluster autoscaler, because it ties to my next slide. One of the challenges with cluster autoscaler is you see these EC2 instances, they are on the same size, right? They cannot, you can create multiple autoscaling groups with different instance types, but Kubernetes and cluster autoscaler will only deploy the same instance on the same managed node group. So let's say if you have a M5 median instance type, you need a new one, it's going to be M5 instance type. And that's the reason AWS has created Carpenter. And I'm pretty excited about this. I think this is awesome. So what is Carpenter? It's an alternative for cluster autoscaler. Carpenter is open source. It's open for the community. Currently only works on EKS. We're waiting other cloud providers to potentially adopt, because I think, we've seen a lot of demand from other customers as well that they want to use these on other cloud providers. The whole idea of Carpenter, I'll put here. Instead of looking for, instead of just increasing another node within your cluster with the same instance type, it makes a lot of smart decisions on what type of nodes would be the best for performance and the best for cost. And on the demo I think the demo will kind of show this. Carpenter will also works for scaling up and scaling down. So I'll give an example. Let's say you have a cluster with 5 nodes, but then you have multiple pods running across the nodes, but some of those pods get removed, randomly across all the nodes. Now you get in a situation that not every single node is fully utilized. And you know what that means? That means money being thrown away. What Carpenter can do, it can look at your Kubernetes cluster high level and see, is this the best way to organize your compute capacity? or can I actually make a smarter decision of bringing one single node or two nodes that can potentially fit off those pods in a much cheaper and performant way? And it's very flexible. Like you don't want to run everything within one node because, availability. But that's what Carpenter does. It looks at those unscheduled pods and makes those decisions automatically for you. So if you
spot on the back end of that,
you could, yeah, you can choose a spot on demand. Yeah, it's on my demo show, you can actually have either or.
And not for persistent workloads, correct?
It can be for persistent workloads. You can actually, when you deploy so the way it works, it looks at the pod itself, like the requirements on the pods. So let's say if you have a requirement that pod needs to actually be deployed in this specific availability zone because you have an EBS storage, you can actually tell, just deploy this pod on this availability zone, and Carpenter will actually deploy a new node on that availability zone. I'll do a demo if it doesn't make sense. We can chat after as well. So that is Carpenter. Yes.
So if you're not using Carpenter, how will it address some of these issues, like for example, underutilizing them?
It doesn't. You need to do it, and that's one of the challenges. What we've heard from customers is the way they do this underutilization is creating multiple managed node groups with different instance types, and you can have like 15 of those managed node groups that now you need to manage yourself. And when you're doing the deployment of your application, you're saying, this application is a GPU, so go to this managed node group, but you need to manually manage that. And that's, yes. And that's the nightmare, yeah.
When it rescales your node,
yes.
Does it kill the current pods?
Yes, so it moves. It queues and creates another one, but it can do rolling deployment. And you can say, so let's say if you have a job, that's a very good question. If you have a job and you don't want the job to be killed because it's like a 10-hour job and you want the job to finish before Carpenter makes any decision, you can actually pass a label on the pod itself, say, do not evict. So Carpenter look at that and say, even though I could optimize, I'm not going to optimize this because, it's the bad, you're telling me not to. So it's pretty smart on that. If people, yes.
Right, no, that's great.
No,
What is it like close to what Kubernetes is doing with Node Affinity or no?
You can use Node Affinity on Kubernetes, or you can use Node Affinity with Carpenter. The way the Carpenter works is just looking at all the pods that are in schedule and looking at all the specific labels that you have on the pod. And let's say you have a taint, and then making the decision for you. So all the Kubernetes native, objects will still work. It's just the way that Carpenter decides to either scale or scale down is based on that. We've seen a lot of interest on Carpenter. If you have an EKS cluster, I would say like everyone that has an EKS cluster at least needs to look at it because it's going to save a lot of, if you're a platform team or a DevOps team, this is a lifesaver. It might not be the answer for every single. There are some edge cases that potentially don't want to use, but most of the time you want to use it. Awesome. Any other questions? Yes.
And you said this was new. When did this come out?
This maybe
3 months ago.
no. This is like a year and a half ago. Yeah, a year and a half ago. Yeah, and I think this consolidation. So what I talked about, like looking at the cluster and moving to more performance nodes, is something that was not. It didn't come with the GA version. It came after. So there's a lot of improvements that Carpenter is actually doing. But if the question is it reliable enough to use in production? Yes, we have customers with 5,000 plus nodes using Carpenter currently. And they actually saved a ton of money just because it's impossible to optimize a cluster of that size unless you have a lot of people looking at that. So that's just something.
Does Carpenter impact the workload if it's over, if it's a long-standing job, does it touch that node?
If you don't have any specific labels telling Carpenter not to do, you will. But you can pass a specific label called do not evict, and Carpenter will look at that, until you finish this pod here, I'm not going to touch.
But it's not to say that, you don't apply the label. In this case, it could kill the work.
It could.
And then that way you end up having to restart the job.
You'll not kill, yeah, you kill, but it will be created in another node. Yeah. But you're going to lose all the states, yeah.
Yeah, it's the state.
Exactly. So you need once you're doing jobs specifically or stateful applications, if you don't want Carpenter to make that decision for you, this is an opinionated way for improving performance and cost. But if you don't want, for whatever reason, like a job, you need to tell Carpenter. And it's just a label. Yes.
So pending pods, existing capacity, unscheduled pods, just-in-time capacity. As a development team, you know, and outsourcing, I'm just curious, how would I be able to help people who on the back end are looking to save money? And right there, right?
Yeah. If you look at companies that are using, you know, Kubernetes in general, not even EKS, and the cluster is quite a big in size, very likely there is idle capacity. And I'm not going to tell you that it's not going to have after Carpenter. There will still be some idle capacity, but it's going to improve and make those choices for you. Rather than have people making those choices and putting work and automation, Carpenter will do that for you.
So you have more independence and
Yeah.
choice.
The way I would phrase, you can leverage the knowledge of, you know, Kubernetes, and in this case, and by the way, the way it works, Carpenter, you deploy a provisioner and deploy a node template, and potentially in the future, that node template will be for Azure, will be for GCP, will be for EKS. So it's going to be open source in that sense. But the way it knows what is the best because it has, you know, the knowledge of the cloud. So for example, on AWS, it knows that there are 500 plus instance types, and it knows what is actually the best for you. Rather than you, like, you know, you look at, it's very overwhelming. You look at the instance type. Even I work for AWS and look at those instance types, like, wow, like I have no idea what would be the most performant for my job, you know, unless spending like a couple of minutes or even hours trying to figure it out. Yeah. Cool. So just because I'm running out of time a little bit, let's talk about it. Let me see. I'm just going to quickly talk about storage. I'm not going to spend too much time, but, you know, I think you had a question about stateful applications. Sorry? Oh, there you go. Yeah, nice. So you're familiar with storage. So Kubernetes is really good at stateless applications, but it doesn't mean you can't have state. And the way you can actually integrate other managed services of storage with your EKS cluster is by using, you know, storage, you know, container storage interfaces, also short, CSI is short for. The way it works is it is a native way to request storage from your Kubernetes cluster. And I just put 3, but there are more integration. You have EBS, which is our block storage solution. You have EFS, which is our file store solution. And then you have FSX for Lustre, which is also a file store solution, but very high capacity. So I'll give an example. Financial customers do a lot of, for example, Monte Carlo simulation, and there is a lot of data that needs to be run on those Monte Carlo simulations. You don't want to keep the data within the cluster itself. You want to externalize, and you can, for example, create an EFS or an FSX for Lustre, where your pod gets attached an interface to the service, but doesn't keep the data itself. So the data is completely outside the cluster, but you actually manage using a managed service. So the CSI is just a way that it talks Kubernetes language to the storage layer. Very high level, but yeah, just want to kind of mention on that. And here is just a little bit of the life cycle. You create a storage class. A storage class can be, in this case, I think we're only talking about EBS, but you choose what type of EBS you want. Then when a user sends a specific, you know, persistent volume claim, you're actually going to go and talk to the AWS and consume that storage here for you automatically. So why this is important is you don't actually need to talk to AWS to request storage. You can just have your platform team or whoever is actually configuring the cluster to configure this, the CSI driver, and you automatically do that for you. So for example, you can just go and mount varlib MySQL. Very bad idea, in my opinion. There's a very big discussion on the community about running databases on Kubernetes or not. I don't think it is still mature, but yeah. So we have disagreements.
It's controversial, and I'm a very controversial person.
Yeah, exactly. Exactly. But then call him if it goes down, okay? Exactly. So yeah, just an example. Well, let's quickly talk about observability. I think you asked, someone asked a question, I think you answered a question like you. When you have big clusters and you have a lot of workloads centralizing on one cluster, there is a big discussion also in the community, and I've done a lot of research and I actually don't have an opinion. Should we do big clusters with a lot of workloads within the cluster, or should we have smaller clusters that have, few workloads? I can see pros and cons for both, but it's a discussion on the community. The only reason I'm saying that is it's really important that you have observability on your Kubernetes. I'm talking about, you can use Prometheus, you can use Grafana, we have offerings as well. I'm talking about more like a out-of-the-box solution. If you're new to Kubernetes, how is an out-of-the-box solution? You can use CloudWatch containers inside. What CloudWatch containers inside will actually do, it's going to ship all logs and metrics from your applications running on Kubernetes into a managed service called CloudWatch. And you see on my demo, you can actually easily see the metrics of your pod. You can easily see the logs of your application that is running within your EKS cluster. This can also integrate with Prometheus metrics. So if you're already doing some metrics using Prometheus, you can integrate with CloudWatch. Yes. Yes, there is OpenTelemetry support, yes. This was like maybe a year and a half ago, yeah, of OpenTelemetry support. This is just a little bit of more like a summary. You collect, aggregate, and summarize all those metrics in a nice visualized dashboard. You even got a map of your cluster. So it gives like a nice out-of-the-box solution. The way it works is you have a CloudWatch agent and a FluentBit daemon set that gets deployed on each node. And those are responsible to collect the data from your cluster and your nodes and shipping that to AWS. And then you can use that on AWS. I promise I'm almost done for my demo. I know it's a lot. Security on EKS. When you're creating EKS clusters, you can configure EKS in like the EKS control plane in 3 different ways. You can have a public IP for your cluster endpoint. That means that the Kubernetes endpoint that you talk to resolves to a public IP. So anyone in the internet will be able to talk to it, assuming they can authenticate it. So there is an authentication layer in the middle, but it's public IP addresses. There is nothing in the middle. Very few reasons why you should use public IP, the public clusters, in my opinion. Companies do, but it's just the way it is. You can use public and private, so you can use a mix approach where you have a public endpoint, but you also have a private endpoint. The private endpoint, if you look at the bottom of my screen, instead of actually resolving to a public IP address, is going to resolve to a private IP address that is only routable within your VPC. So let's say you have an application that needs to talk to Kubernetes, you can just using this, you automatically by DNS resolution figure out if you are within the VPC, if you have an endpoint, a VPC endpoint, to return your EKS on VPC IP addresses. Or what is potentially what I've seen most customers do is just private only. That means that no one from the internet will be able to talk, even if whatever reason they have your credentials, they're not going to be able to talk to your cluster. So that's kind of the way it works. It creates a EKS on ENI, Elastic Network Interface within your VPC, and that is just a routable IP address that you can talk to. And if you have, well, one of the questions developers have, well, I'm developing locally, how do I connect to that cluster that is private? Well, we can just, most enterprises will have like a direct connect, which is a link between your on-premise or office to AWS, or you can just VPN, use AWS VPN to be within the same IP address scope. Any questions on this? Okay. Last, that I want to quickly talk about it. On AWS, we are super strong on shared responsibility, right? And we want to educate customers about this. And this is one of the security share responsibility that we have actually, published. When you're using a managed service, it doesn't mean that AWS is going to be able to do everything for you. That's some sort of a high expectation that customers don't fully understand. This picture here is talking about EKS self-managed node group. So it's the example where you manage your own data plane. When you're using that, you can see on the green one, it means that it's AWS responsibility, and on the blue one is the customer responsibility. So you can see everything on the control plane will be AWS responsibility, upgrades, scalability, API server. But everything else on the managed node groups is going to be your responsibility because you are actually now managing those nodes. When you actually go to a managed node group, remember 2 types, manage node groups, the operating system, the integration to kubelet, you know, the CRIs, the AMI versions, and the template configuration is all managed by AWS. So you don't need to worry about that, but you still need to worry about like, how are you scaling those nodes? Do you have a VPC? You know, what is the specific, I think there's a type, it should be EKS cluster configuration. What is the cluster configuration that you have there? And all the deployments, you know, your deployments, your pod distribution budgets, you know, the container image is things that you as a development team will need to actually be responsible for. And then finally, EKS Fargate, it removes the worker node scaling because now you just ask AWS and AWS is going to create that for you. So you don't even need to worry about that. And the control plane, of course, is taken care of. So, and on the end of my presentation, just want to show this. If you want to learn more about EKS or play around with EKS, you can just go on our documentation, of course. But you can actually go to the EKS workshop. We've actually just published the version 2 of our EKS workshop. It goes from creating a cluster, creating a load balancer, talking about scalability, talking about observability, storage. I've actually created a storage section, so if you have feedback, let me know. But I would recommend going there. And then finally, this is more for folks that are familiar deploying EKS. About a year and so ago, we've released what we call EKS blueprints. If you've done EKS before, it's really a pain to create a cluster. It's just a plane. It's just literally a plane. Not just a cluster, but everything that goes around the ecosystem. I want to create a cluster. That cluster, I want to have, you know, the AWS load balancer controller installed, the CloudWatch logs installed. I want to have all the add-ons, all the specific configurations. I want the VPC to be created. That was a pain. Now you can actually use EKS, both Terraform and CDK. Terraform is just an infrastructure as a code open source tool, or you can use CDK. Which is our own version that you can use actually programming language to deploy stuff on the cloud. And you can use this, there is a GitHub repository, there is a workshop. If you're doing that in production, I would recommend actually taking a look at this. Before I jump into the demo, any questions? Awesome. Okay. Everyone, please pray to the demo gods. There you go. Hopefully that is a good sign. Okay, so let me just, there we go. That was a good one, that was a good one. So, okay, so let me just make sure this is working. Okay, so this is just an IDE, Cloud9, that you can actually spin up on AWS. This is just giving me a Linux bash that I can actually do some things and show to you. Behind here, you're gonna see that it's my cluster. So I have a cluster that have 2 nodes, M5 large, and I can actually show you that it's not smoke and mirrors. So this is my cluster. It's running version 1.93. Shame on me because I am not running the latest version. I was just lazy because it's demo. It's a supported version, but it's not the latest one. Oh, it's big enough, sorry. Is it better now or no? Better now? Oh, I'll make it bigger. Thank you, thank you. So remember I talked about what actually the control plane provides you is literally just this API server endpoint. So this is control plane for me. This is the only thing I care is just this API, and that's how I actually talk to the control plane. So if you look at the compute, you can see I have only one managed node group, and that managed node group has, if you go on the nodes, it only has 2 nodes, and if you see here is 192 and .7. Just to show you enough line to you, 192 and .7. Those are, you can see this is just CPU utilization is fully utilized because why not, right? Exactly. Play with my life. It's like, so what I have, I actually have this command so I don't make any specific mistake. I have this container. It's just a container that I've created with Nginx running and a React application. I'll show you this application. There we go. So it's just a very simple application, nothing fancy. I'm going to run this application Kubernetes. So right now it's just running as a Docker. It's not running on my Kubernetes cluster. I've already deployed the application, but I haven't actually deployed a pod. So I have a deployment with 0 pods. So let me show you. kubectl get deployment. So if you're not familiar with how you interact with Kubernetes using CLI, is using this tool open source called kubectl. I have already authenticated with my EKS. All that has been done. But I just want to see what are the deployments that I have on my application, on my cluster, on my default namespace. So I already have this container. The container one here that you saw here is here, but you can see that there is 0 replicas. So I'm just going to scale this down. And I want to keep an eye as I scale this. I have Carpenter running here. So I want to do actually the demo together. So if you see here, kubectl get pods -a. I have already Carpenter running on this cluster. And Carpenter, because I have no more space and because I'm telling not to use any of those, because those are managed by manage node group, I want Carpenter to manage this specific application. I'm just going to do kubectl scale. I'm going to say a deployment. I'm going to tell the name of the application or name of the deployment, which is called native New York. And I'm going to say replicas. I'm going to say 3 replicas, right? And I'm going to do it here. So it says scale. Now, if I do kubectl get pods, voila, yeah. You can see that it actually created a new node. It's creating a new node. So that's Carpenter. And Carpenter was smart enough to say, I'll need to do this a little bit smaller so you can see. It created M3 median for me automatically. And it created on demand because I've told it to create an on demand. And I'll show you why it created an on demand. So if I go to describe my deployment, you can see that some of the labels I've created, where are you labels? Hang on, let me just do it. Uh-oh. Just give me a second. Yeah. Sorry, technical problems. And we look at the labels. Let's see what those labels are. So you can see the rolling up data strategy here, the labels. So I created a node selector and I said, I want you to just deploy this application with nodes that have intent and apps as labels. So I've configured Carpenter to actually create those labels. And I've said, I actually need this application to run on-demand compute. I don't want to use Spot. I want on-demand. And I want to actually use AMD 64. So I want to use x86. If you're familiar with ARM, you can actually run Graviton 2 on AWS, which is just the ARM version. And that's why I created here. And now, fingers crossed, if I check my pods, it's creating. So this might take a little bit if this hopefully works properly. Oh, it works. I was just lucky that I did and it wasn't created. So you can see that it's now running, but that's not it. No. So what? Like you can run a pod that is not anything fancy. This deployment has a service and it also has an ingress on top of the service. So behind the scenes, actually, I told EKS to create a load balancer for me on AWS. The way I'm going to tell you. So first we look at the services. I have this cloud native service node port created. So when you're doing ingress, you need a service and then ingress on top of that. So you can see that there is no external IP address on this service. When I actually check my ingress, remember it's a layer 7 application load balancer, it created automatically this for me. And if I go and I copy this might not still be running because it's passing the, there you go, it's actually running. So this is actually running on my Kubernetes cluster. And every time I refresh, it should be automatically redirecting on all those 3 pods. If I have 10 pods, it's going to be across all those 10 pods. But let's just do one more thing. Let's just change my application, push to my container repository and deploy the new version of the application. Why not? So I have this React app. Let's just going to say cloud native. Let's see here. EKS, not a dim. I'm playing around now. So I've changed my container. What I need to do, I just need to build again this container. Let me go inside the path. Going to build this container again because it's already cached. I've built here. It's just going to be a little bit more fast. But while I wait for you, I just want to show that I have a repository already created. and the repository has just one image with the tag v1. I'm just going to create another image with v2 and push that. It's running here. You can see some outdated. This is not using best practice of development, as you can see. So I've created, now let's just push. I just need to tag this specific image. I'm just going to tag, and now I'm going to push to my ECR repository. I need to authenticate it. There you go, live demos. Authenticate it. There you go. Now I'm going to push. So this has been pushed. If I go to my ECR, yeah, it's here. So I have version 2. There you go. But now let's actually push that, to my cluster. I can just easily run this command. You can see this command will be kubectl. I'm going to say change the image of this deployment. So in reality, we're not going to be running these commands if you're a developer. You're going to have an YAML object and just applying that YAML object. But for the sake of the demo, I'm just running the command itself. And you can see here that the command says to use version 2, right? So I'm going to go here, I'm going to run this command. It says updated. And if we see now, it's probably going to be creating. So it's terminating some of them. Actually, it already did. So you see how fast it was, right? I was not using any rolling update best practice, but you probably want to do it slowly. I did very fast. So you can see that it's terminating one. And if I refresh again, you only see 3, right? And because, so Carpenter, if you look at the bottom, was smart enough to say, you don't need to change anything. You're just changing the image and creating 3 more pods. You have space for that. Now, if I go here and I refresh, there we go. So not a damage. So one last thing I want to show to you is how Carpenter can actually create spots. That's where I think is really the benefit of Carpenter, is by creating a lot of these spots. So I have this other application here called Inflate. It doesn't do anything. It's just using a pause container and use, yes, please.
Say it again, why one of the pods was terminating.
Oh, it's just because when I ran, it's gonna force, you are asking why this was terminating and not fully terminated. Yeah, because the way Kubernetes will do on deployment, to drain any connection that there is on that pod, you create a new one, and once that new one is creating, it's going to terminate it. So I just got lucky that when I run kubectl get pods, 2 has already been fully removed, and this was just in the process of being removed on the cluster.
And that's the old V1?
That was the old V1, yes. You can see by the time, 5 minutes, and the new ones are just seconds. Right? So this Inflate is just using a pause container, and the idea is it's going to request 1 CPU per pod and 1.5 gigabytes of RAM per pod. The idea is just to show how Carpenter can actually scale that for you. So, and by the way, because I'm not specifying any label to this deployment of Inflate, it's going to prefer to use spot. Let me show you what I mean by that. So if you go on the provisioner, so there is a custom resource that Carpenter deploys called provisioner. And that provisioner is responsible to actually deciding what to do. And you can be super flexible, but I've decided to say, you can support both on-demand and spot capacity. If I don't specify that I want on-demand and there is a spot availability for me, it's also going to try spot. So if I go here and I do kubectl, scale, deployment, inflate, and let's just do -- replica 10. The name of the deployment. Oh, no. Oh, why that should have something. Hang on. Give me a sec. Deployment, inflate. Oh, replica. Maybe that's the problem. Hang on. Replica, of course. Yes. There you go. Sorry. You see, live demo. I always get you. So if you go here and you check the pods, so first, this is really important. Now I need 10 vCPUs and 15 gigabytes of memory for those unschedulable pods that I tried to create, because that's what each pod requires. You can see that he automatically decided that this big 4x large instance using his pod, because that's the most cost performant, assuming I can tolerate no terminations. It's gonna take a few seconds, potentially a minute or so, for this to be up and running. And you might ask me, maybe I'll ask a question. Now it's my time. Why do we have 14 pods here and not 10?
case one of those spots get taken?
No, almost. I think you probably, you've asked a question that ties back to that, not to put on the spot. So the reason why it has 14 pods and not 10, remember the daemon sets will deploy on each node. So if I am to just filter which pods are running on this node, kubectl, just do a grep for that specific node. You can see that most of them are inflate. Sorry, I need a -a, 1 second. I need all namespaces. There you go. So I have all the inflate, but I have CloudWatch, I have FluentBit. This is a little bit hard to see, so there you go. So I have CloudWatch, I have FluentBit, AWS node, and kubeproxy. Those 4 are daemon sets. Every time a node gets created, those daemon sets are going to be deployed. Sorry?
What did you say? You have what?
Daemon sets. So daemon sets are just containers that will run on each node. If I have 100 nodes, you run on each node. That's why you see 14. But you see that Carpenter is smart enough, and I promise I'll stop making you sleep, and it'll be the last thing I'm going to do today. If I scale this down and I say 0 replicas, Carpenter will remove that node because it doesn't consider daemon sets, because daemon sets, can just be ephemeral. It can just be removed by nature. So you see in a few seconds, if everything goes well, this node will get removed from here. Yes. Oh, sorry. Yeah, good question. So a spot is the way that AWS has created. So let's assume you have a data center, right? And it's really hard, by the way, it just got removed. So you have a data center. It's really expensive for AWS to not have every single resource fully utilized. So a spot is a way that AWS created, I don't know, many years ago, 7, 8, 10 years ago, that it gives for a much bigger discount price instances that are not being consumed on demand. Meaning, so there is a big catch there. You can use those instances as a spot. Those instances will fluctuate if there is capacity or not. And if there is capacity that is needed back, let's say a real customer is paying for that on-demand instance, AWS is going to give you as a user 2 minutes a warning before removing the instance from your account. It's going to terminate the instance. So you can use a spot, making sure you understand that your application can be rescheduled on other nodes, or by the way, you can use this spot not only on EKS. This spot is something you can use on EC2 by itself and other services, but it gives you up to 93% discount on the on-demand price. And on-demand is just you request an instance, and that instance is for you for as long as you're paying. Yeah.
So you actually using Spot, you run your application on other people's.
No. It's still on AWS. Nobody has access to that. It's still yours. The way it works is, let's say AWS infrastructure has 95% being used on demand, meaning customers that are paying the fixed price of that instance, right? There is 5% that are not being utilized. AWS is those instances can be spin up on the infrastructure. So you can still use those instances, but because you're paying much cheaper, if there is a time that resource needs to be claimed back, that resource, the compute, not any data or anything like that. AWS is going to tell you 2 minutes warning. It's going to remove that instance from your account, and it's going to serve another instance with another data, but using the same virtual landscape for you. Yes. Good question. Yes. Yes. So it worked. I love that question. So you can see I'm excited. Actually, behind the scenes, when you deploy Carpenter, you can deploy a cloud formation that creates a SQS. SQS is just a queue, a managed service on queue. And the SQS will get messages from the AWS health system, which tells that queue, hey, this instance is going to get terminated. Talk Carpenter to start killing those instances for me. So that's the way it works. And it does not only do that on the spot, but let's say there is a maintenance on a specific rack that is being placed on your instance. Carpenter will also get the health notification and automatically move you around. So it's pretty smart on that. Yeah, that's why I was excited. Yes. Yes.
Basically, replace the nodes with larger nodes or right-sized nodes. Those are something for your
Depending on the service you use. So if you're using EBS, for example, which is a block storage, there are ways. Kubernetes by default is not going to do that. There is automation, you can actually do that. But if you're using like EFS, which is a file system managed service on AWS, it automatically scales for you. So I think the answer is depending on the storage service that you're using. But if the question, maybe let me go back. If the question is, will my node storage increase? No. It only, yeah. Okay. Okay. So GP2 to GP3, by the way, for people that are not familiar, is just an elastic block storage volume type. It's just a newer version. You can actually just go, when you create if you're talking about specific on EKS, you can specify your storage class to only use GP3. But if you already have GP2s and you want to upgrade, you can just go on the console with one click, upgrade to GP3, and there is not going to have any, or CLI, it's not going to have any outage or anything like that. It does behind the scenes automatic for you. Yeah, yeah, awesome. Any other questions? Cool, that was pretty much it. Oh, sorry. Yeah. I love the question. Yeah, that's one of the things that autoscaling group was not good at, because you have a 2-minute, waiting period. That's the reason why Carpenter got created, because it doesn't talk to the autoscaling API. It talks to actually the EC2 Fleet API. There is no groups. We call groupless Carpenter. So it can call as many, like hundreds of requests per second, and you automatically do that for you. That's actually what we've heard from customers. Like, listen, I just scaled down, but now I need to scale up because another application is asking, but I need this, have this waiting period. Like, what's up with that? Carpenter was saying that. And I think I'm overselling Carpenter, but you should try. I think it's pretty good. There you go. I'm happy. I can go home. Yes.
When it comes to choosing an instance type,
yeah,
are you able to set like guardrails in terms of Carpenter? I need be within 15% of max CPU, for example.
Ooh, okay. So is there a reason why you do that?
I'm just curious.
So normally you would, so one thing that is important to talk about Carpenter, the way it makes those decisions is by using at the request of CPU and memory on your pod object. So let me show what I mean. Let me just get the pod here. Get pods quickly. Let me just get. Let me just go maybe here. Uh-oh. Second. So on the pod, you have, hopefully this has, I'm pretty sure you would have memory, some side here. Oh my God, here, resources, right? So the way the Carpenter will look, you look at the requests and you reserve that, you always reserve that space. Like when he's doing the math, he's always going to look at those metrics, right? If you keep only 50% node of utilization, I mean, it could be 50 at the time that those pods are running, but he's reserving this CPU and memory. You can see here that, this one is 80%, because potentially my pods are, just allocating 88%. It doesn't mean that if I check the CPU and memory of this node, there is actually 88% utilization. It's just allocating that space. So Carpenter will make the decision for you. So it is not that it's utilizing, but it's fully, because it's very common in Kubernetes that if you don't properly set requests and limits, you have noisy neighbors, right? If you just deploy a container without requests and limits, and you have like a lot of containers within one node, because Kubernetes doesn't know how much it needs to allocate, you can have a lot of containers that gets a spike, and then you potentially get you're using memory that other containers might need because you haven't reserved the capacity. So Carpenter will look at those when you're deploying Carpenter, always make sure you set those two things. I don't know if I answered the question, but yes. Yes. Good question. Yeah. So I'll show you. Hang on. Good. So yes, it runs always true, no more than 2, no less than 2. It's an active standby approach. It's not a daemon set. We don't want to consume more resources than needed. So the way it works is there is always going to be one pod responsible for the activities. If that pod stops replying, the other one will take the responsibility until the second standby pod gets. So it's a deployment, not a daemon set.
It sounds like it should be on 2 nodes, right?
100%. Yes, and it's done automatically. I mean, if you only have 1 node, that's why I have 2 nodes on my managed node group. I mean, it's just best practice as well. But if you have only 1, then those 2 pods will be the same. So you want to make sure you have 2 nodes. Yes.
Does Fargate come with Carpenter?
No. So because Fargate, you don't scale anything. Like you don't have an instance to scale. Like you don't have capacity scale. The way Fargate works, it doesn't work at the instance type. It works at the, remember I showed here the request and limit. Carpenter will actually create a pod with those configurations. So behind the scenes is creating what we call a micro virtual machine with that compute and memory available for you. So there is nothing to scale pretty much. It's just actually, you have a pod, you requested 2 gigabytes of memory, you request 1 CPU, that's what I'm going to give you. And I'm going to manage that for you. So there is no need for scaling.
Is that basically like a Firecrack with the open image?
It is, I don't think it's Firecrack. I think Firecrack is Lambda. I think some sort of like fork of Firecrack. I don't know, to be honest. I don't think that is published externally, but it's a micro VM. I think it's not as, because Firecrack is more like functions go up and down. I think those are more like long-lived. So I would assume, if I need to guess, it's just a fork of a Firecrack. It's not as fast as Firecrack, by the way. When you spin up a Fargate, it's not going to be as fast as the Fargate. Any other questions? Cool. That's pretty much it I had from my presentation. Thanks for everyone. For sharing. I know, hang on.